In Mexico. And today I will present the topic, Who is Who in Identifying Sentiments on Twitter.
The following is the content of my presentation, which begins with introduction, justification, problem statement, general objective, methodology, results, conclusion, and finally the references. As a first step, we must know one of the techniques that are in the field of artificial intelligence, which is focused on enabling communication between humans and machines through natural language, which is known as natural language processing, where, currently has become very important in everyday life with technology, facilitating tasks such as virtual assistants who understand questions, systems that analyze opinions in social networks, and especially the most natural interaction with devices and applications. Natural language processing techniques go beyond improving human-computer interaction, and have a great impact in areas such as business, education, health, and politics, by allowing the discovery of patterns and trends in large text data sets. A fundamental application within natural language processing is sentiment analysis, which allows us to understand how emotions and opinions are expressed in natural language, making it a very valuable tool for different sectors, because it allows us to understand the reactions of users about different products or services, which allows us to adjust commercial and social strategies according to the mood of the users. In this work, we focus on the political arena, where leaders use this sentiment analysis tool to evaluate public opinion, because it helps them to adapt their communication and political proposals according to voters' feelings. The constant growth of social networks such as Twitter makes this tool even more relevant within natural language processing, because it represents a very valuable source of data, allowing us to extract insights from comments that can be processed in large volumes of unstructured data. Other uses that can be given to sentiment analysis are the dissemination of news, opinions about education, opinions about products or services, or generate advertising, among others. Taking into account the exponential growth of social networks, Twitter stands out as a virtual space where millions of users share their opinions, emotions, and experiences in real time, which allows this platform to allow us to understand the complexity of human expressions in a digital world. However, the analysis of feelings in Twitter presents several challenges due to the nature of the messages, where the texts are usually short, with abbreviations, and informal expressions, where to overcome this ambiguity it is essential to use a multifaceted approach that combines different techniques and methodologies. Therefore, we propose the use of base classifiers, lexical resources, and deep learning techniques to accurately identify and categorize the content of tweets as positive, negative, or neutral. Our biggest challenge we faced was the automatic identification of sentiment in unstructured texts found on Twitter, so we made use of an architecture that combined base classifiers and different lexical resources, in order to develop automatic tools that are able to extract the information, and thus better understand whether sentiment identification in unstructured texts can be achieved using different machine learning techniques. Our objective was to develop automatic tools capable of extracting subjective information from natural language texts, such as opinions, or publications, which generates new structured and processable knowledge for its application in decision-making systems. Here, I show in this diagram the implemented methodology, where as a first step is carried out the selection of data, and then take them to a level of pre-processing which generated multiple variants of the data set. Then we made use of classification techniques using supervised learning methods to classify the tweets according to their sentiment as positive, negative, or neutral, being these evaluated in two classification scenarios which are cross-validation and training and test set. A meta-classifier was also implemented that combined the three best models to generate better predictions, and finally, convolutional neural networks were used to compare the results obtained and identify the most effective approaches. But in order to explain it in a better way, let's go step by step. The first thing is to choose a dataset which is named Twitter and Reddit Sentimental Analysis Dataset, which is made up of about 163,000 tweets about the elections in India in 2019 about President Narendra Modi, which is previously labeled. From this database was carried out the selection of two datasets that would be used in the experiments, one consisting of 1,000 tweets and another by 5,000 tweets, where for the choice of. These data messages were filtered using keywords, or hashtag. We move on to the pre-processing part. First of all, stop words or empty words were eliminated, which are those that have no meaning by themselves. Then, all uppercase letters were converted to lowercase letters to homogenize the corpus. Then, the tokenization of the tweet was performed, segmenting the text into phrases or words. Next, lemmatization of the tweet was carried out, with the purpose of reducing morphological variability and improving the accuracy of text processing. And finally, the information gain technique, which helps to measure the relevance of an attribute within a dataset, was applied. Here I show the classification scenarios that were used for the experimentation of our system. First I show cross-validation, which is one of the most commonly used data resampling methods to evaluate the true prediction error of the models, adjust their parameters and avoid overfitting. In 10-fold cross-validation, the learning set is partitioned into 10 disjoint subsets of approximately equal size. The partitioning is carried out by randomly sampling cases from the learning set without replacement. For training and test sets, the model is initially fitted to a training set, which is a set of examples used to fit different types of model parameters. Therefore, this classification scenario is based on dividing the whole dataset into two subsets, whereby dividing the dataset into a training set and a test set, the majority of this data is used for training, while on the other hand the smaller part is used for testing. In my work I used a percentage of 80 to 20, where 80% of the data was used in training and 20% in testing. In both classification scenarios we made use of learning methods that helped us to classify the comments according to their corresponding label. Finally, I show the results obtained, where first of all we made use of deep learning using neural networks with the database without any type of processing, followed by the use of the automatic learning technique known as machine learning. Taking into account the whole pre-processing process, 4 different files were generated for each data set, 1,000 and 5,000 data, applying the different stages of pre-processing. Where we have the baseline, which is the set without any previous pre-processing, complete pre-processing, stop words elimination, lemmatization and information gain were applied, generating 1091 attributes, only information gain to select the most relevant attributes, resulting in 1,000 attributes, having only the pre-processing of stop words and lemmatization, without applying information gain, obtaining 177 attributes. Finally, as an additional step, a meta-classifier was implemented combining the 3 best learning techniques, based on the best percentage of accuracy obtained in the experiments, support vector machine, Bayes and decision trees, J48. The results obtained are shown in the following comparative tables and graphs, where you can see the best results for each of the created sets, using both classification scenarios. Having as the best result for accuracy within the 1000 data to SVM, which has all types of pre-processing with 79.79% for cross-validation, and also within the training and test sets we have SVM with 78.14%. While for the data set of 5,000 data the accuracy is handled by the same learning algorithm, which includes all types of pre-processing, having an increase in accuracy for cross-validation of 83.76% and for CEP 83.47%, where it is evident that SVM achieves the best result, which includes all types of pre-processing and especially the inclusion of information gain over the other types of pre-processing. In conclusion, we can say that sentiment analysis is an